Everybody, welcome to our lesson 2.3. We're going to be talking here about angle properties in triangles, and we're going to call this part one. I'm just going to break this set of notes into two parts. So part one is just going to deal with the first section, majority of the notes, which are looking at triangles and angles inside a triangle as well as an exterior angle, an angle that's outside of a triangle. And the second part, in a separate video, will look at parallelograms. Okay, let's get started. So a couple of angle properties in triangles. Some of these we've already gone over in class, so I'll just quickly go through these again with us so that we can be really clear. Any angles that add up to 180 degrees are called supplementary angles. And so all straight angles, so any angle that is on a straight line, the sum of all those angles on that straight line have to equal 180 degrees. So for example, if this was 140 degrees here, okay, to figure out what that other angle is, it's simply going to be 180 degrees subtract 140 degrees, which is going to come to be 40 degrees. And there's my answer. So I know that any supplementary angles have to add up to 180 degrees. So this is always true. The other thing that is true about triangles is that the three angles of a triangle must also equal 180 degrees. So for example, if we have triangle ABC here, A plus B plus C, and these could be, for example, this happens to be an isosceles triangle, where angle A and angle C are the same. But regardless, it doesn't matter whether it's an acute triangle, a isosceles triangle, an obtuse triangle, it really doesn't matter as long as we remember the rule that three angles of a triangle must equal 180 degrees. So angle A plus angle B plus angle C must add up to 180 degrees. If we have a right triangle, okay, one of those angles is equal to 90 degrees, and that's going to be this angle right here, our right angle. So if we call this triangle DEF, like so, what's true is that angle E and angle F plus angle D must equal 180 degrees. But considering that one of these angles is equal to 90 degrees, that means that the other two angles here, angle E and angle F, must add up to the other 90 degrees, because 90 plus 90 gives us 180. So angle E plus angle F will equal 90 degrees. The other two angles of a right triangle will always equal 90 degrees. There's an interesting relationship that happens when we have any type of a triangle, and that triangle is on a straight line, so that we have an exterior angle as well to consider. And let's have a look at that. And it has to do with this supplementary angle relationship. So here we have a blue triangle ABC on a straight line B to D, and this green angle that we see right here, this is called an exterior angle. It's not in the triangle, so that's why it's referred to as exterior. And any of the angles of the triangle are called interior angles. Okay, so these are all A, B, and C here are all interior angles. Angle A, angle B, and angle C are interior, meaning that they're inside the triangle. Angle C and our exterior angle, angle ACD, are right beside each other. So these two angles right here, we would call those adjacent, meaning that they're on the same line. They're going to be supplementary angles. And the word adjacent means that they're connected to each other. These are called adjacent angles. And it's true that they are also supplementary angles, and they will equal 180 degrees when we add the two of them together. And these other two angles then, so angle A and angle B, these other two angles are not attached to the exterior angle, and they're given the term non-adjacent angles. So angle A and angle B are called non-adjacent angles to the exterior angle. So they're not connected, they're across from it, okay, and they're non-adjacent, meaning that they're not directly attached to it. And there's something that's going to be true about those two angles, angle A and B, when you compare it to the exterior angle. So if we think about it, we know that any two angles on a straight line are supplementary, meaning they have to add up to 180 degrees. We also know that all three angles of a triangle must add up to 180 degrees, and so we get the following relationship. Two angles of a triangle, okay, that do not share the same vertex, so in other words, they're not directly connected to the exterior angle, are called, let's just write that for ourselves again here, non-adjacent. Non-adjacent angles. And let's think about what's true here. So we've got a diagram here. So let's just put in angle C. Let's say the angle C is equal to 55 degrees. Okay, and let's think about what the relationship is between angle A, B, and angle C. Okay, I'm going to make angle A and angle B different here. Well, one thing I know is that three angles of a triangle must equal 180 degrees. So one thing is true. Okay, all three angles in a triangle must add to 180 degrees. So that tells me that angle A plus angle B plus angle C equal 180 degrees. Which means that I'm not exactly sure what angle A and angle B are, but I know that angle C is 55 degrees, which means that angle A plus angle B will be equal to 180 minus angle C, angle 55 degrees. They will make up the remaining degrees, okay, of that 180 degrees. So angle A plus angle B together are equal to 125 degrees. That is true. Okay. The second thing that I know is that my exterior angle to this triangle right here, this is called the exterior angle, and I know that it is on a straight line with angle C, and I know that it has to be equal to 180 degrees when I add 55 degrees and the exterior angle together. The sum of those two angles must be 180 degrees. So we have supplementary angles. Okay, I know that supplementary angles also add to 180 degrees. So that tells me here that my angle C in my triangle plus the exterior angle, and in this case here, we can go ahead and call that's going to be angle ACD, that's my exterior angle. Those have to be equal to 180 degrees. And I know angle C is equal to 55 degrees, so angle ACD is 180 degrees minus 55 degrees, which is 125 degrees. Okay, so what's true then? This exterior angle over here is equal to the sum of the non-adjacent angles. Angle A plus angle B added together are going to give me the same measurement as my exterior angle. And that's our relationship. So it looks something like this. The exterior angle is going to be equal to angle A plus angle B. In other words, the sum of those non-adjacent angles. And that's just written above for us as well, so we don't really have to write that again. So the sum of the non-adjacent angles will always give me the same angle as that outside exterior angle. So we can use this relationship to quickly solve for missing angles in any triangle that's on a straight line. And so, for example, a little bit lower down on your page here, we have two different triangles. Let's put in some values here. So let's go ahead and let's make angle B in our first triangle. Let's make angle B equal to 63 degrees. And let's make this outside angle equal to 112 degrees. Okay, so let's find all the remaining angles here, which is not a difficult thing to do. This is my outside angle of 112 is my exterior angle. Okay, and what I know is true is that that exterior angle is going to be equal to angle A plus angle B added together. And so it's 112 degrees. That's going to be equal to angle A, which I don't know the value of that, but I know angle B is 63 degrees. So if I move that 63 degrees to the other side, 112 degrees minus 63 degrees is going to give me my angle A, and that is going to come out to be 49 degrees, and that's equal to angle A. So there's my angle A. I can fill that in for myself now. So this angle here is 49 degrees. And then the last angle that I have, my angle C, or angle ACB, this angle right here could be solved in two different ways. We could quickly say, well, angle C here, the third angle of this triangle, is going to be 180 degrees minus angle A and minus angle B. Or we could see that it's on a straight line, so I know that it's supplementary to 112 degrees. So finding our final angle here, so angle C, we'll call this angle C, is going to be equal to 180 degrees. We can subtract either 49 and 63 or just subtract 112 degrees and we get 68 degrees. So we could use either of those rules to solve for that angle. And there's my final answer. So 68 degrees goes right here. Great, let's just do one more together. So this time we're going to be given the two non-adjacent angles. So 55 degrees is angle A, and angle B is 64 degrees. So if we're given those two angles, again, we can quickly figure out the exterior angle, and then we can figure out the last interior angle as well. So I know that the non-adjacent angles, angle A plus angle B, are going to give me this outside angle. The sum of those non-adjacent interior angles are equal to the exterior angle. And so let's add those together. So we have 55 degrees plus 64 degrees is equal to 119 degrees. And that is going to be the value of my exterior angle. So 119 degrees goes right here. Finally, solving for my last interior angle, so angle C. There's, again, two ways I could solve for this. It will be the last angle of my triangle, so 180 degrees, subtract the other two angles that I know. Or I recognize that it's on a straight line with the exterior angle, and so it's supplementary. So I could also use that relationship. 180 degrees minus 119 degrees is going to equal 61 degrees. And there's my remaining angle, 61 degrees. These are pretty straightforward. The relationship is helpful. You could also have figured out just using supplementary angles and the relationship that there are three angles in a triangle that must add to 180 degrees. But it's also helpful for us to recognize this relationship between the exterior angle and the two non-adjacent angles inside the triangle. Let's do one more example here where a triangle is actually extended so that we have a triangle lying on two straight lines. So we can now tie in a few different relationships. Let's go ahead and label this. We're going to call this line A to B right here. And let's make this triangle then come down to the vertex C. and we'll make this point here in the middle D, and then we'll make the horizontal line that we see C to E, just like that. Okay, just so that we can label some of these angles. And let's say that we're given this exterior angle here, and it's equal to 128 degrees. And let's say that we're also given angle B, and it's equal to 51 degrees. Okay, solve for all the remaining angles. And while we're doing that, we can think about the relationships between them. So again, there's more than one way to start this question. But one of the things that we might start with is recognizing that we have an exterior angle here, and it's going to be equal to the two non-adjacent angles inside the triangle. So I could immediately solve for my angle C. Okay, so let's go ahead and do that. So angle C, I know that angle C plus angle B is going to equal 128 degrees. That's true. So angle C is going to be equal to the exterior angle subtract angle B. Okay, so let's go ahead and solve for that. So angle C is equal to 128 degrees subtract 51 degrees. And what do I get for that? 77 degrees. So there's my angle C, 77 degrees. And I could go ahead and fill that in, 77 degrees for angle C. So I could use that relationship. That then allows me to solve for the third interior angle of my triangle. So let's go ahead and do that. So this angle right here, this is angle, we can call this angle BDC. Okay, that's the third angle in my triangle. Well, it's going to be equal to 180 degrees minus the other two angles inside my triangle, or I recognize that it is supplementary to the exterior angle 128 degrees, so I could also use that relationship to solve. So it'll be 180 degrees minus 128 degrees, which is going to give me 52 degrees. Okay, for that angle right there. So we can go ahead and fill that in, 52 degrees. The remaining angles are really easy to solve for because we can use our relationship between any two lines that intersect. And I know that when we have two lines that are intersecting, the angles that are vertically across from each other, or vertical angles, are equal. So I know that this angle right here is also going to be equal to 128 degrees. So if I were to prove that over here, I know that angle ADC is going to be equal to angle EDB because they are vertically opposite, or in other words, they're vertical angles and they are equal. The same thing is true here of this angle EDA. It is vertically opposite from angle BDC, so it is going to also be 52 degrees. It's the mirror image of that other angle. So the same thing is true here. Okay, angle EDA is equal to angle BDC because they are also vertical angles. And vertical angles are equal. So we've solved for all the remaining angles in this triangle, and the exterior angles as well. We're going to do two slightly more difficult questions. Again, just trying to take all of these different relationships and apply them to a problem. We're also going to look at two types of triangles here in the next question. So let's draw ourselves a diagram. We're going to draw, first of all, a straight line from A to D. So we're going to call this A to D. Okay, the horizontal line. And we're going to draw here from D up to B, we're going to draw an acute equilateral triangle here. Okay, so we're going to draw a triangle where three sides are equal. So this is going to be triangle DBC. Okay. Let me go, sorry, let me put my C down here. So I've drawn myself a acute equilateral triangle on my line. Okay. And what's true about a triangle that is acute, all of the angles are less than 60 degrees. And the fact that it is an equilateral triangle means that it has 3 equal sides, and it will also have 3 equal angles. That's going to be true as well. And then I'm going to go ahead and just connect my line A to B here. Okay. And I'm going to make, even if it doesn't quite look right on your diagram, I'm going to make angle A, or line A to C, okay, equal to line C to B. So this is going to be an isosceles triangle where 2 sides are equal, but A to B is longer. It is not equal. Okay. And this is also an obtuse triangle because I have an angle inside that's greater than 90 degrees. And what we'd like to do here is we're going to prove that angle A, this angle right here, is equal to 30 degrees. So we need to go ahead and prove that, and this is all we're given. So let's start off by examining some relationships that are true of our angles, as well as some things that are true about the two types of triangles that we have. So let's go ahead and solve this. So first of all, I recognize here that I have well, altogether I have one big triangle, triangle ABD, but inside I have 2 triangles. And let's go ahead and split those 2 triangles up. So first of all, I have the triangle ABC. Okay, triangle ABC is an isosceles triangle. So an isosceles triangle tells me that 2 of the sides are equal. So A to C is equal to B to C. Those 2 lines are equal. What is also true about having 2 sides that are equal, the angles across from those sides are also equal. So if I come along over here, angle A, okay, is going to be equal to angle B. Those 2 are going to be equal. This is true. Okay, and angle C is going to be a different angle. So that's something that I need to know. So first of all, A to C is equal in length to B to C, and angle A is equal to angle B in that triangle. Okay. Let's come along over here and have a look now at our other triangle. So we'll split this into 2 parts. The other triangle I have is triangle BCD, and this triangle is an equilateral triangle. How do I know it's equilateral? Because I see that these markings that I have on each side are the same, which tells me that all 3 of their side lengths are equal. Okay, so C to B is equal to B to D, and that's equal to C to D. So those 3 side lengths are equal, 3 equal sides, and there's also 3 equal angles in an equilateral triangle. And there's also 3 equal angles. Okay, well, if there's 3 equal angles, that tells me that the 3 angles, angle B here, angle BCD, and angle D, I know that those 3 angles must all equal 180 degrees when added together. And if they're equal, that means that each one is a third of 180 degrees. So to figure out each one of those angles, I can take 180 degrees, the total angles of my triangle, and divide them by 3. This is always true of equilateral triangles. Each angle is equal to 60 degrees in my equilateral triangle. So let's go ahead and fill that in. So this angle is 60 degrees, this angle is 60 degrees, and this angle is 60 degrees. Okay, there are my 3 angles of that equilateral triangle. Now I can figure out angle A, angle B, and angle C of my other triangle. So what I know, if I come over here to my isosceles triangle, is I know that this angle here, angle ACB, is an exterior angle, and it's going to be equal to the sum of angle B and angle D added together. It's also going to be supplementary to the 60-degree angle that's adjacent to it. So I can use either relationship to solve for that. Okay, so this exterior angle, which is going to be angle ACB, is going to be equal to 60 degrees plus 60 degrees added together, or 180 degrees minus 60 degrees. But let's use this new relationship that we have. It's equal to the sum of the non-adjacent angles, and so it's equal to 120 degrees. Okay, so we'll go ahead and fill that in. 120 degrees is that angle right there, which means that angle B and angle A have to make up the remaining degrees of my triangle. So I know that the difference here is going to be 180 degrees minus 120, which is equal to 60 degrees. So they have to be each equal to a half of 60 degrees because they are equal angles. So they're splitting the remaining 60 degrees equally. So we can go ahead and solve for those then. So I know that angle A plus angle B are going to be equal to 180 degrees minus 120 degrees. So they're equal to 60 degrees. I also know that they're equal. So they split that 60 degrees equally, which means that it would be true to say that angle A, or 2 times angle A, is equal to 60 degrees. And so angle A is going to be equal to a half of 60 degrees. And it's equal to 30 degrees. I can come up then and fill that in. So angle A is 30 degrees and angle B is 30 degrees. And I've solved for all the angles in both of these triangles just using the relationships that I know are true about equilateral triangles, isosceles triangles, and exterior angles to any triangle. Let's look at one last problem, and then we're done for this part of the lesson. Okay, we've got one more diagram below. Again, you're going to be given a couple of angles here. So let's call this triangle on our line triangle ABC. And we're going to come all the way up here to D, this line, and we'll make this long horizontal line the line A through to E. Okay, and let's give ourselves a couple of angles. So we have 62 degrees, which is angle B, that's given. Let's go ahead and make this angle BCA equal to 71 degrees. And let's let DCE be equal to 47 degrees. Okay, given those angles, can we find the remaining angles, and can we determine whether the lines A to B and C to D are parallel lines? Draw that a little bit more. Okay, so we're asking ourselves, are those lines parallel? That's the questions that we want to know. Okay, let's start off by figuring out what our missing angles are, and then we can look at a relationship that will prove whether those lines are parallel. The first thing that I could do is solve for my angle A. Okay, that's a very easy angle to solve for. So angle A, I know, is part of a triangle, so I know that angle A is going to be equal to 180 degrees. Subtract the other two interior angles. So 62 degrees, subtract 71 degrees. And so angle A is equal to 47 degrees. And there's my answer there. So I can go ahead and fill that in. 47 degrees. That's true. Okay, finally I can figure out what this other missing angle is here. Okay, this is the angle BCD. Come on over here and let's show our proof of this. So angle BCD, well, how will I determine that angle? Well, I recognize that I have a straight line here. I have this straight line right here, which means that all of the angles on that straight line must add up to 180 degrees. They must all be supplementary angles. So the question is, what is this missing angle? Well, it's going to be equal to 180 degrees, subtract the other two angles on that straight line. So we've got 180 degrees, subtract 71, subtract 47. Okay. And that is going to give me 62 degrees. And my reason for this is that these are supplementary angles. Supplementary angles must add to 180 degrees. So I'll go ahead and fill that in on my diagram, 62 degrees right here. Let's ask ourselves now, are the lines A, B, and CD parallel? Well, we need to find a relationship that proves this. There are at least two relationships that I can see here. One relationship that I see is that I have a Z shape formed that looks like this, and I know that alternate interior angles must be equal. Okay, so yes, right away I can see that they are equal. So those two lines are indeed parallel lines. So we're going to say yes, AB is parallel to CD because, well, one reason is that alternate interior angles are equal. So alternate interior angles are equal. We see that they're both equal to 62 degrees. Okay. The second reason that I can see here just by looking at this is that I also create an F shape when I look at this diagram. I can see here that my interior angle of 47 degrees is also equal to the exterior angle of 47 degrees. I have an F on its back, and so I could also say here that's also a great proof of that. So corresponding angles are equal as well. So my corresponding angles are equal to 47 degrees, and that is also a proof that these two lines are parallel. Great. That ends today's first part of this lesson. There's a short video to follow here where we talk about parallelograms. So thanks for joining me for now. I'll get you to watch the second video, and then you can carry on to try some problems.